Okay, so this video is an introduction to an investigation that I'd like you to try, which is finding the derivatives of a slightly different function. And this one that we're looking at now is y is equal to sine x. But what I want you to investigate is what happens if I change what's multiplied by x here. So what I mean by that is, what if I had 2x, sine 2x, or sine half x, or sine 3x? I want you to investigate those possibilities. So I have a little bit of a tutorial here that we'll go through just to give you some hints. If I change the value of a, you should know that that changes the period of the function. So let's just change it to 2. Okay, so naturally, and we've gone over this before already, naturally you can see that you knew that the maximum slope of the original function of sine x was 1 from a thinking point in the past. But now you can see when we change the period that the slope is steeper. So what used to be 1 is now squished together, and now it's steeper. Let me just show you that again. So look, the slope here is -1, the slope here is 1. If I drag this a to 2, the slope is steeper. So what I want you to do is drag this point around and determine basically try and guess what that function is. And it's still a trig function, so you've got that to go off of. Look at the amplitude, look at the period, all those sorts of things. Try it again for 3 and for a half and things like that. If you need to erase everything, you can just click on that move tool and sort of give it a little shake, and that will erase everything. So that's sine. The same rule will apply for any function, so I'd like you to do it for a couple of other functions as well. We can try the natural log of ax, and you'll get this here. Actually, let me move this point over here first. So now the natural log of ax we get here. So now it's a is 1, which it usually is. So now we're looking at y is equal to ln ax. And then I'd like you to change a. Change a, and then mold the derivative around. Now you knew that the derivative of the natural log of x is 1 over x. Well, what is it if it was the natural log of 2x? And you can play with this and plot your own functions and see how you're doing. Remember that the same rule will apply for all functions, including trigonometry and logarithms. So the same rule that you find in the trigonometry, you should be able to bring over here and see if it still holds true. Okay, and then I'd like you to do one more function, which would be e to the ax, like this. So then we'll have y is equal to e to the ax. So see what happens when I drag this point around. Okay, so if a is 1, which is what we explored earlier, you'll notice quite quickly that the derivative is just e to the x, which we knew already. But what if it was e to the 2x? What's that derivative? Remember, the same rule applies for all the functions. Okay, so good luck. Have some fun. This is a very, very important investigation for what you're going to be learning really soon. Okay?